Good evening. I wanted to do a video on a number of items here. If you look down, you'll see a few things have changed, and up as well slightly elsewhere, including some new indicator lights up there. So this is a little update on the setup here, and I'll cover things briefly and perhaps cover things more in depth in later videos. But I figured what I'd first do is just show you everything as I bring it online. Let's do that. I apologize for the noise of these two guys. I'll explain what those are, or rather you'll see them in just a moment. Again, I apologize for the racket. The reason for that buzzing, and hopefully it isn't too loud, is they are synchros. They are synchro-driven angle position indicators, as shown. And what they do is they take any synchro signals and they display them in degrees and minutes of angle. I think I will turn these off until the gyro settles, because they'll just keep making that buzzing sound. But you can see here, I've got two of them. The left one is the pitch of the gyro, and the right one is the roll. So I'm going to turn them off for the moment, and I'll go over, while the gyro spins up, some of the new additions here. As you saw, this light is now on. I know it's hard to read. This one says gyro warning, and underneath it says press to erect. The term erect is a gyroscopic bit of nomenclature that typically means to set the gyro in a level capacity ready for use. So you notice when I first turned the gyro on, it sort of did this indicator thing and went wobbly and crazy. And that's because it was self-erecting, in that it was finding its zero origin, both x and y axes. So the term erect is used in that capacity. So this light will go off when the gyro reaches its full speed. From previous videos, you may have noticed this light here. This light will come on when the signal is valid. The gyro has reached up to speed. So this light will go off. So typically, since most aircraft indicators only light when there's trouble, as opposed to staying lit when there's like a status of some kind. Oh, there we go. Just went out. So what that means is the signals coming out of the gyro are now valid, and this also doubles as a button, the push to erect button, and I'll show you what that does in a minute. And you may also notice a GPWS flap override, this blue light here. And we've got the below Glideslope as before, and then a Glideslope canceled button. And you may also notice the addition of these little command bars. If you were paying attention, they came down from their hiding spot and are now center in the frame. So you'll notice I have no flags visible. I've been able to simulate every input to this, with the exception of localizer. I do have the input, but I don't have it simulated right now, so for a later video. But let me go ahead and turn back on these noisy devices, and I will show you how they work. So pay attention to the digits themselves. And I'm going to move this off screen so you can actually see what's going on here. But as of right now, I'm rotating the gyro around. I'll keep it in frame for a little bit just so you can see. So as I pitch up, you'll notice that, here, I'll lay this down here just so we can see it. So I'll get us to 30 degrees, and you can see here on this one, we're reading about 30 degrees, as we are on the indicator. Reading about 360 right here, and that's because I'm not pitching, or rolling I should say. You can see that as I pitch up and pitch down. The indicator, as usual, shows my attitude. But now I have a numeric readout to go along with that. And of course it works in all axes, as does the roll. I'll go ahead and roll. You can see. Now, to give you some idea of just how sensitive these things are, I'm going to go ahead and jiggle the gyro just slightly. It's sitting in a like a bushing here that does allow a little bit of play. It's designed to reduce vibration to the gyro itself, which is in the cylinder. But if I move this ever so slightly, you can see how, I mean, you can't even tell I'm moving the actual gyro. But if I move it to the left, and then to the right, these indicators are so sensitive that they're picking up just the most minute of movements, and they're sensitive in both axes. So you can see as I kind of jiggle it around, it's doing it, and if I leave it alone, they stay put. Now the reason why they're not reading a perfect 0 degrees is because this table is ever so slightly out of level. In fact, I can tell you exactly how out of level it is. This should be reading 0, but it's reading 359 and basically 11 minutes. And this one is reading 359 and basically 45 minutes. So there's 60 minutes in a degree. These are fractions of a degree, so 60 minutes equals 1 degree. So you can see how very close to level this table is and the gyro itself. And again, a very sensitive device. So these movements are so fine, they don't even really register on the indicator, but they don't fool the actual readouts. And the reason why they are able to be so precise is because in here there are synchros, and these connect right to the synchros in here. So it's a synchro to synchro connection, and they are, as the name implies, synchronized. And very accurate, as I've mentioned. Here we are at 50 degrees. Pitch up, you can see we're at 49. I'll go to 70. And we're getting to about the limits of what this gyro can do. And I'll show you what happens if you exceed that. Right now, the gyro is basically vertical. You can see how it's gone completely into gimbal lock. And that movement you see is not me, that's the gyro spinning on its axis, trying to find a balance. You can see those digits are going crazy. Now, you'll notice the gyro is back flat, yet the reported numbers and the indicator are way off. Now, one of the downsides of gyroscopes is, or the limitations I should say, is they have this ability, this gimbal lock. And when they do that, you need to re-erect them. Hence this button right there. This button will force that homing and 0 mode, so it'll balance itself out. So I'll go ahead and press that button. You'll notice the light has come on, the warning light, and you'll notice that valid light on the gyro has gone out. And if you watch the roll, you can see it is changing, and simultaneously the gyroscope is now erect. I let go, and our signal's now valid again. So what determines the amount of gimbal lock that can happen to a gyro really just depends on what happens to it while it's in that lock. So sometimes it's more severe than other times. There it is upside down. And I'll put it down. Now it's really off. So I'll go ahead and hit that button again. And you can see here how we have both indicators now recentering themselves. And you can also watch here how it's also recentering. And the GPWS is barking because it is past its bank angle. So this button I'm pressing, this gyro warn button, lights when the gyro is not in its erect state. Likewise, again, as I mentioned, the green LED is off when the gyro is not in a flattened state. So also the flag on the indicator shows up as well. So you can see on at least one axis, pitch, we're more or less home, yet the roll still coming into 0. Now if I let go of this button, yes, the signal is valid, but this doesn't know that it's off-centered until I hit this button. I mean, you can very plainly see that you are not level, even though the gyro is level. So I'll hit it again, and it will keep going. There's switches inside the gyro that know when it is not level, but those switches aren't tied to the valid symbols and indicators. Those simply just mean it's reached speed. So you can see we've stopped. We are now back to level. So I'm going to go ahead and turn off these. So they are quite loud. And the reason for that buzzing and loudness is they're actually buzzing at 400 hertz, which of course, as you know from previous videos, is the frequency of the AC power that powers this device and the synchros themselves. So again, that buzzing is basically 400 hertz. And the reason why they buzz is because the synchros there's a servo loop in there, and I'll do a video on gyros. on synchros. And the way they generally work is they're tied together with a servo motor and the synchro, and as the synchro turns, they're linked to the servo motor, and there's an error determining circuit, and basically as that synchro rotates, it gets to a point where it gives that feedback to the circuit, and it reaches that point where it should, servo shuts off, and it's set. But these devices are about from 1960, I'd say, and there are probably some worn out parts in those synchros, and it buzzes more than it should. But as you see, they do work very well. So I'll go ahead and end this video here. It's getting a little long, but in the next segment, which I will do right after this one, I will describe some of these new lights and how they apply to the ground proximity warning system, and what these little guys are here that came and swung out of there. In fact, I'll just give you a quick little tip here. If we turn that off, see how they went out of view, and now they'll come back. So those are called command bars. Okay, see you in the next video.